Hey guys, Mr. T here. I wanted to go through a dimensional analysis problem with you, kind of walk you through it. We kind of did this one in class today, but we did run out of time. So I wanted to go ahead and do that. It is important. Alrighty, so what's our question here? How many atoms of carbon are in 4 moles of glucose? Okay, so the first thing we need to do to unpack this problem here is, well, what's glucose? So chemical formula for glucose, as we found out in class, looks a little something like this: C6H12O6. Okay, what that's telling us is we got 6 atoms of carbon here, 6 atoms of hydrogen here, 6 atoms of oxygen here, all mashed together in a what? In a solution, in a beaker? No, this isn't a what. This is considered a what? It's considered a molecule. So, ladies and gentlemen, that looks like the chemical formula for a molecule of glucose. And that's important. You're going to see that, and you're going to see that in a minute or two as to why. So the next thing we need to do is find out how to set up our dimensional analysis ratios. So we start out with what they give us, which is what? 4 moles. Note, the abbreviation for moles or mole is just MOL. So let's start getting used to doing that. So 4 mole of glucose. We're going to divide that by 1, because mathematically we know anything divided by 1 is itself. And we're also going to put a parenthesis around that to get into that dimensional analysis structure. We need to set up our new ratio, our next ratio. And what we're doing here now is the first thing that we want to do is look at to see how are we going to possibly eliminate this unit. Mathematically, if we have something in the numerator and the same thing in the denominator, it cancels each other out, whether it's a number or a variable. And in this case, you can consider mole of glucose mathematically as a variable, X, Y, Z, if that helps you out. So 4 moles of glucose. Well, what we're going to do is do a little housekeeping here. And we're going to put our 1 mole of glucose here in the denominator. I know to put it in the denominator because I'm looking to eliminate this on this numerator. And just to remind you, when we're putting these ratios in parentheses next to each other, we're actually multiplying them out. Now, here's what's important to understand as well. Now, what we're going to do is 1 mole of glucose here. We're going into atoms of carbon. Well, we can't go directly from moles to atoms in this case. So what we need to do is a little step in between. And that's where we need to go back and think to ourselves, a mole of anything is how much? Meaning, if I have a mole of glucose, if I have a mole of milkshakes, if I have a mole of particles, if I have a mole of atoms, if I have a mole of molecules, how many do I have? Avogadro's number, that's where he steps in here. So let's go ahead and put him here. 6.02 times 10 to the 23rd watt. Well, we agreed that if we look something like this and we're talking about glucose, it's a molecule of glucose. So Avogadro's got to comply and tell us that his units in this case will be molecules of glucose. Okay. See why it's important to make sure you write your units out, because here I have moles of glucose and now I have molecules of glucose. So be careful how you abbreviate, you might get mixed up. So that's why I went ahead and I wrote that out. Good, little housekeeping for our dimensional analysis, because we're not done. We're not looking for molecules of glucose. We're looking for atoms of carbon. We're not finished yet. But that means we need to get rid of molecules of glucose. So our housekeeping dimensional analysis tells us that what we need to do is put our molecules of glucose here in the denominator. Why did I put it here? Same idea. We want to cross out our molecules of glucose. But now we have to think to ourselves, what is the relationship between molecules of glucose and atoms of carbon? Okay, is there one? See how there is. Ready? So what we're going to first do is at least put in our unit. Get that out of the way. We're going to put atoms of carbon, and that's just atom C, C being naturally the chemical symbol for carbon. How many atoms of carbon are in one molecule of glucose is what we need to ask ourselves so we could find out what number to put in there. So what we do is we go to the molecule, or we go to the chemical formula of glucose, the molecule of glucose, and we see that we've got 6 atoms of carbon. So that's why we're putting the number 6 here. Okay, are we finished with our dimensional analysis setup? Well, let's go ahead and see. So what we're going to first do is start eliminating like terms that are in the numerator and the denominator from this entire equation. So moles of glucose goes away, and then so does molecules of glucose. That goes away, and we are left with something called atoms of carbon. Is that good? That is good, because that's what we're looking for. How many atoms of carbon? Atoms of carbon. So our dimensional analysis has now proven to ourselves that we've set these ratios up properly. The numbers that are in the denominators and the numerators are the right numbers, the right way they have them, okay? Now what we got to do is the actual math. So the math looks like this: 4 times 6.02 times 10 to the 23rd times 6. First thing I want to do is kind of simplify that, because we can just go 4 times 6 first. I'm going to go ahead and do that. 4 times 6 is 24. And I'm going to put that here on the bottom. And I'm going to multiply that by 6.02 times 10 to the 23rd. Okay. And it's all divided by 1. I'm going to avoid putting that 1 in there. There's no need for that. 24 times 6.02 times 10 to the 23rd is actually 144, right? 0.48 times 10 to the 23rd. All I did was multiply 24 times 6.02, and that scientific notation part just kind of comes down there. We're not finished yet because this is not in proper scientific notation. So what we need to do is move our decimal place over 2, because our decimal place is currently here, right? 144.48 times 10 to the 23rd. So when we move this over 2 times, we move it to the left twice. So we increase this by 2. Move it to the left, increase. Move it to the right, decrease. Okay. Move it to the left, increase. Move it to the right, decrease. Move it to the left, increase by 2. This now becomes, instead of 10 to the 23rd, increase by 2 to the 25th. This decimal place now gets erased over here through the magic of whiteboard, and we have 1.4448 times 10 to the 25th. Are we finished? I don't like that answer. I'm going to go ahead and I'm going to round that up to a 1.45 times 10 to the 25th watt. We have 1.45 times 10 to the 25th. Well, we're looking for atoms of carbon. That's what we're left with our dimensional analysis. So I'm going to go ahead and put that atoms of carbon. Okay. And yes, ladies and gentlemen, that is our answer. That is our solution. Okay. So that gives you a general idea of what we did today in class. Hopefully that helps you out. Certainly, obviously, take the minute or two to pause, rewind as needed to go over that. I'm going to go ahead and take a picture of this board and send this to you as well in your Google Stream. So you have the ability to simply look at the solution. And if you could follow along on the solution by a still page, by all means. Otherwise, just watch this video and watch me kind of walk through it. All right. Take care, guys. Hope that helped. Take care. You mean I wasn't recording it?